Here's another one. Imagine that the numbers 1, 2, and so on 100 are written in a row, in this order from left to right. In one move, you can swap two numbers, but not two random numbers, but only two numbers at a distance of 2, by which I mean two numbers that have exactly one number written between them. For example, if we used 1, 2, 3, 4, 5 instead of 1, 2, and so on 100, we could do this. So at the beginning you have 1, 2, 3, 4, 5. Then let's swap 3 and 5 because they are at a distance of 2. They have just one number between them. So 1, 2, 5, 4, 3. Let's now swap the 1 and the 5 because they're also at a distance of 2. So 5, 2, 1, 4, 3. And let's now swap the 2 and the 4. They also have just one number between them. So 5, 4, 1, 2, 3. Now back to the original question about the 100 numbers. Here's the question. Can we, by such a sequence of moves, end up with the numbers 100, 99, and so on 1 in this order from left to right? In other words, can we basically revert the order of the numbers? So, for example, for n equals 5, we are kind of there already to some extent. 5 and 4 are already in the right places. And now if we swap 3 and 2, we will be done. And we can swap 3 and 2. They satisfy this condition. So in the case of 5 numbers, we're done. In the case of 100 numbers, it's probably going to be harder to try. So like I claim that the answer is no. Why not? If you think about what happens with any single number, in a move, a number either moves two places to the right. For example, this 3 has moved 2 positions to the right, or it moves 2 places to the left, like this 5, or it just stays in its place, like this 2. So in a move, each number either moves 2 positions to the right, or moves 2 positions to the left, or stays in its position. Hence, the parity of its position stays unchanged. In particular, 1 will always remain at an odd position because it started out at position 1, and since the parity of its position doesn't change, wherever it goes, the position will be odd. But if we are to end up with the numbers 199 and so on, 1, then 1 must end up in position 100, which is not odd. So this is impossible. So it's a very simple invariant. In this case, there is a lot of invariants. We just picked the parity of the position of 1. We could just as well have argued using the parity of the position of 2 or of 3, as there is 100 invariants, in fact. So, but just looking at the number 1 was enough. So for 100 it doesn't work. For 5 it worked, but for 100 it doesn't.